Have you ever tried to access a file and then tried to modify it and then you get error as permission denied? Sad, right? That's a very common problem which you face on daily basis if you are using a Linux based machine. In today's video, we are going to talk about how Linux permissions can be managed, and we are going to see few details about the same. We are going to focus on the commands which are involved to modify and update these permissions. Talking about Linux permissions, these are majorly used to manage or handle all the file structure which is available within your operating system. It makes much more easier for the admin to manage who can access a particular file, who can edit it and do certain execution to the same. Let's get deep dive into how we can actually change and work with this. If you are working with Linux based environment, in every file and directory, people are associated with three particular types. The first type is user or owner. The second is groups, and the third are others. Let's understand one by one what this refers to. Talking about the first one, that is user or owner, it is considered to be the one who has created that particular file or directory. The owner will have all the permissions to work with that or to modify those. Second are groups. Groups are set of users who are having a same permission. For example, you are working in a team, your team might be a set of group. They can have permissions to do modification in that particular file. There can be a group of testers, developers, so on and so forth. The last one is others. Excluding owner and a particular group, all others are considered as others. When we have others, so if we take example of developer and tester, let's say the file has permission of owner and then developer. Tester group will be considered as others. Now that we have understood who all can associate permissions, we need to understand where I can actually check these permissions. So for that, we are going to see a command through which we are going to understand how we can check what all permissions you have. So for this, we are going to hit a simple command, that is ls-la. This command is used as list, and then there is an option that is all and long. So as soon as I hit enter, I am going to get all the details about my directory. Now just try to understand what all things are mentioned over here. So the first part, if you can see, these are majorly dedicated for the permission part. The rest, let me explain you. The numbers which you can see 5, 21, 1, 3, so on and so forth, these are majorly number of links. Now what do you mean by number of links? So for example, there is a directory. Inside that directory there can be multiple other directories and files. So from here you can understand how many number of files or directories are present inside that given directory. But the catch is, how do you understand which one is a directory or which one is a file, right? So for that, there is the first option, or I would say first letter, which you need to understand. If D is written, that means it's a directory. If there is an hyphen, that means it's a file. So now it makes much more sense. You can see after directory there is 21 written. That means there is a directory, and inside that directory there are 21 either files or directories mentioned over here, and so on and so forth. The next part is root. This is for mentioning the owner of that particular directory or file. So herein you can see everything is root. That means this has been created by root. The next one is for groups. So for which all groups it is allowed or it is accessible. Again here root has been mentioned, but this can change, maybe developer, tester, as I mentioned, right? Then the next one is, these number are the file size. What's the size of that particular directory or file? And the last one is the date or the time when it was created. So from here we can see what all permissions we have. Now we have seen D, but what about this R, W, and so on and so forth? These are the actual permissions which we want to check. There will be 9 characters to be precise. Each of these are representing what permission each one of them has. So try to understand this. 9 characters, we need to divide it 3, 3, and 3. First 3 characters are dedicated for users. next 3 characters are dedicated for groups, and the last 3 characters are dedicated for others. Now we need to understand what all permissions are offered. So there are majorly 3 types of permissions: read, write, and execute. So whenever we have RWX written over here, that means the user is going to have read, write, and execute permission, and this goes on. Let's get into more details of the same. Now that we have understood different types of permissions and how we can check those permissions, now let's just talk about how we can actually modify these permissions. Before going to that, there are basically 2 types of permission or 2 types of methods through which we can modify this. The first one is alphabetical order. The second is numerical method. The first one is where we are going to use some alphabetical keywords through which we are going to update these permissions. Now let's try to give few acronyms, that is U, G, O. Definitely U stands for user, G for group, and O for others. Now the permissions, that is read, write, and execute. I'll add one more as A, that is all. We are going to use this and then use an operator through which we can either add a permission or we can remove the permission. Let's have a demo of the same. So here, as we can see, all the permissions which are there. Now for my hello.c file, let's check the permission. So the first one is hyphen, that means it's a file, of course. Now there are three characters: read, write, and hyphen. That means for user it is read and write permission. Then there is r hyphen hyphen, that means for group it's only read permission, there is no write or execute permission, and same goes for others as well. Let's try to add an execute permission for the user itself. So with the alphabetical method, I'm going to use the command chmod, and then I'm going to mention u plus x. So that is chmod. So change permissions. U is for user, plus is for adding the permission, and x is I want to add execute permission. Definitely I need to mention for which file I need to do it, right? So I'll just say hello.c, hit enter, and let's just do ls-la to list down, and you can see it gets highlighted, and over here x has been added to my file. Similarly, let's try one more method. Let's say we have chmod, and then I want to remove permissions from group. So chmod g minus r, and then hello.c, and let's just do ls-la, and you can see it has been removed from here. Similarly, you can add, subtract depending upon whatever use case you have. We can do it for multiple as well. Now let's just talk about the second method, that is numeric method. In this method, all the 3 permissions are represented by a number. Let's start with the fundamental, where we don't have any permissions, that is no permission. It stands by 0. So if 0 is denoted, that means there are no permissions. If 1 is mentioned, that means there is execute as a permission. If 2 is mentioned, that means write as a permission has been given. And if 4 is mentioned, that means read as a permission has been given. Now question might arise, after 2, why 4? Now for this, we need to understand simple binary number. We have 3 equal brackets, or I would say 3 spaces which we need to fill. If everything is 0, which is equals to binary 0, that means no permissions are given. Now the last one, if you remember from the character part, the last one was given for execute. So for the last, if I mention 1, that is true, the binary number will be 1, which means permission is execute. So in the previous method, we saw the permission representation by 3 blanks. Those were represented by read, write, and execute. Now when we did ls-la, we saw those 3 hyphens. Now imagine these 3 blanks or hyphens as single bits. So for these bits, if I mention 0 on each bits, the binary or the value will become 0 and the decimal value will be 0, which means no permissions given. Similarly, if I add 1 at the last bit, that means it is going to give for execute. Hence, the decimal value of this binary conversion becomes 1. So 001 equivalent to 1. Hence, we use 1 for execute. Similarly, if I fill the middle blank, if I replace that 0 by 1, so my binary value is 010, which is equivalent to 2 in decimals. Hence, we are giving right as 2. Similarly, if I do 1 at the start, the value becomes 100. Hence, it is going to become 4 in decimals. That's why we skipped 3 and we are getting 4 as a representation. If I do 1, that is read, write and execute, now the sum is 2 plus 1, that is 3. So if I mention 3, the permission will be write and execute. Let's do a demo and understand in a better way. So herein we had our files. Now the command still remains the same, that is chmod. Now we had 3 major entities: owner, groups and then others. So how do we define these numbers for them? So first I need to define what permission I need to give for particular entity. So for example, for the owner, I want to give write and execute, and for this number was 3, so I'll mention 3. Similarly, I want to do the same for group as well, so I'll mention 3 again. And then at the last, for others, I only want to give execute permission, so for that the number was 1, so I'll mention 1. So hence the entire number becomes 331. That gets divided into 3 different parts: 1 for user, 1 for group and 1 for others. And then I need to mention the file name. I hit enter and then let's just check ls-la. Now here you can see write and execute and only execute. So that's how number system works. Now there are multiple ways or multiple combinations which you can try to give different permissions. A very common or mostly used permission number is 777. That is all permissions to everyone. So 7 is for all, again for 7 for group, 7 for others. So let's just try that. 777 hello.c, and then if I do ls-la, here you can see all the permissions has been added. Now there are other permissions like 600 and 400. These are also commonly used. That is for giving only read permissions or read and write permissions. So that's a quick dive into how you can manage file permission within Linux-based environment. There are 2 major types which we discussed: numeric and character-wise. Try this. There are multiple combinations which you can attempt, based on which you can practice how file permission actually works. That's it for the video. If you liked it, do subscribe to the channel and happy learning.